Hey everyone, it's Bennett Townsend again, and I'm going to be going over IMAPS and DNS protocols for our server security class this week. So first, let's go over IMAPS. So through my research, I was able to find that IMAPS is an email retrieval protocol, and it actually stands for Internet Message Access Protocol, where the S stands for secure, and as we've reviewed previously, is encrypted traffic over SSL TLS. So IMAPS utilizes a mail server to store the received emails, which allows the recipient to view and manipulate, if needed, the mail. So it does provide the option to organize mail, such as utilizing folders, flags, and it'll also actually save draft mail. And it's all, again, stored on the IMAP server. And that server is compatible with other email clients as well and can store and organize their emails also. So IMAPS is also an intermediary between your email server and your email client. So when you read an email, it's actually being read off the stored copy on the server, which means the email can be accessed from any device in any location. So when a user wants to access their email, they'll sign into their account, for example, Outlook, and this will initiate the connection via IMAPS, which is port 993, and the headers for every email will be displayed. Now, the messages will only be downloaded locally if the user requests it, and they'll only be deleted off the server if the user explicitly deletes them as well. So also the server can be configured to allow offline accesses. Also, where IMAPS has been shown to be much more efficient than other email retrieval protocols such as POP3S that we covered last week. So because the emails are being stored on a server, it can require a large amount of storage, as you can imagine. So it is important to ensure that your email provider provides sufficient amount of server storage. Um, and if obviously if not, you'll find yourself having to delete emails on a frequent basis. So a few hardening recommendations I found, one of which was require SSL TLS encryption. So requiring SSL TLS, it'll ensure all the traffic or email traffic specifically using IMAPS or the IMAPS server will be encrypted. So if traffic was ever to get intercepted, it wouldn't be readable. So by default, SSL TLS setting is set to yes, which means that the server allows SSL traffic, but changing it to required requires it to be SSL and will drop any non SSL traffic. So this can actually be done by changing the SSL settings in the dovecot config file that we already have on our Linux server. And it's simple as changing the SSL equals yes to SSL equals required. So if you have your own signed TLS certificate, you can also change the SSL cert and SSL key locations in the document to use your own CA certificate. So it isn't necessary, but it can be changed. And you must also change the port from IMAP default port 143 to 993. 143 is not SSL protected and 993 is, which can also be done in the same config file. Another hardening recommendation is utilizing LDAP. So LDAP is a lightweight directory access protocol, and it's a server that authenticates and can be an efficient and more secure way to authorize users in Dovecot using IMAPS. So because the authentication for IMAPS or Dovecot server will be authenticated via the LDAP server, the password storage scheme will be independent to what is configured on the LDAP server. And that way the users will be more easily managed, reducing any possibility of rogue accounts. Um, Another is enable email filtering. So enabling email filtering, it can be implemented in IMAP server, such as any email filtering services, such as Sieve is one that I found, and it can actually define rules and actions to validate and perform specific actions for incoming mail. It and more or less will prevent any unwanted or potentially dangerous emails from being received in a user's inbox. So next we'll go over DNS. So DNS actually stands for Domain Naming System, and it's commonly referred to as the phone book of the internet. The DNS server translate our commonly known and used domain names such as google.com to IP addresses that are unique to those specific hosts. Um, there is an authoritative and recursive, so we can go over both of those. Authoritative and recursive DNS servers are both integral parts of the DNS infrastructure, while each performs a specific and different role. So the recursive DNS server are actually at the beginning of the DNS query and is a system that will respond to a recursive request and tracks down that DNS record. And the recursive server tracks down the record by making a series of requests until it finds that authoritative DNS name server that was requested. So this process is streamlined and avoids making multiple requests when able to cache the path, which will result in the delivery of the requested resource much earlier than the DNS lookup. And authoritative is the DNS server that holds the DNS resource records and is at the end of the DNS lookup chain. So it'll respond to the queried resource record and will allow your browser making the request to reach the requested IP of the website you're trying to reach. So let's say you want to visit a website and type in mywebsite.com. When you type that into your browser and hit the request, that request is, or sorry, when you hit enter, the request is received by a DNS recursive resolver, which then queries a DNS root name server. So the root server responds to the recursive resolver with the address of a top-level domain or TLD, TLD DNS server, such as .com or .org are examples of top-level domains. So in our example, we used .com. Yep, .com. So a request will be made to the .com TLD by the resolver, and the TLD server will respond with the IP address of the correlating site and query, and the query is sent the domain's name server. I'm sorry, and a query is sent the domain's name server by the recursive resolver. And then the IP address is then returned to the recursive resolver, and the DNS resolver responds to the web browser with the IP address of the initial domain requested. And then your browser will then make a HTTP request to the IP address, and the server at the request IP returns the web page to your browser, and then it'll be displayed for you to use. So a couple hardening recommendations that I found. So first we can go over Windows DNS service that we implemented on our ISS servers. So a couple hardening recommendations for that is to implement split horizon DNS. So split DNS uses the same DNS domain name for both the internet and internal domain member resources, but the server roles are assigned separately. You have one for the internet and one for the ADDS domain. So these internal services on the DNS server should never be allowed external users, or should never allow external users to access it. So splitting the DNS this way, it'll add an extra layer of protection and ensures that the sensitive information on the internal DNS stays separate from the internet side and ensures only the DNS server outside of your firewall can be accessed by queries from outside that firewall. Next is configure DNS policies. So configuring specific DNS policies can create a more secure environment by filtering out any bad DNS queries with potential threats. These policies can include traffic management, blocking IPs from specific known malicious sites, and enabled forensics, where malicious DNS requests are redirected to a sinkhole instead of the requested computer. Also enable logging. So enable logging on a DNS server will allow you to easily track previous activity to the DNS server and can help with forensics and or the overall health of your DNS server. And then I did add one more. and it is DNS cache locking. So DNS cache locking is a feature that controls the DNS cache. Um, it, it's a feature that controls when the DNS cache can be overwritten. So having this control will prevent a malicious user from overwriting the cache and redirecting the traffic to a malicious site. So with cache locking enabled, it'll prohibit cache records from being overwritten for the duration of the TTL value. So for Linux, we used bind on our Linux server. So um, similar to ISS, hide internal IP address. So it's advised to keep, again, the internal network information separate from external IP address. So in bind, again, it's imperative to hide this information from any external users. And it can be done either on a global section or on a per zone basis. So you actually need to configure the etc bind9 name.config file and specify which IP can make certain queries, as well as transfers, recursion, listen on forward, and forwarders. So it'll ensure only the necessary machines have the capabilities of seeing the internal network. Next is change bind user to non-root. So to limit accessibility and lateral movement within the environment or your environment, it's recommended to create a separate user for each service, such as bind, and creating a non-root user to run these services and only has permission within bind to prevent this from happening. And then last is build shrooting jail. So the complexity of bind has created some security flaws. So creating this jail environment will limit any damage to only the specified environment if anyone was able to gain access. So that is everything that I found. Here are my references for my research and information, and I look forward to what everyone has to say about my findings, and I look forward to seeing what everyone else found.